Hello everyone, myself Sujita Sunwar, roll number 21NS0-236. This is my second video on the topic Junction Field Effect Transistor JFET. Now, let us understand what is meant by JFET. Junction Field Effect Transistor is one of the simplest types of field effect transistor. Contrary to the bipolar junction transistor, JFET are voltage control devices. In JFET, the current flow is due to majority of charge carriers. However, in BJT, the current flow is due to both minority and majority charge carriers. Since only the majority of charge carriers are responsible for current flow, JFET are unidirectional. The first working model of junction field effect transistor or JFET was proposed in 1952. Now let's see the JFET construction. There are two types of JFET, N-channel and P-channel. The N-channel is more widely used. There are three terminals. Drain, source are connected to the N-channel. Gate is connected to P-channel, P-type material. Now, let's see the sum of JFET operating characteristics. There are three basic operating conditions for JFET. Number one, VGS is equals to 0, ID increasing to some positive value. VGS less than 0, VDS at some positive value. Voltage control resistor because the drain current is controlled by the gate voltage. Now let us see JFET operating characteristics. VGS is equals to 0 volt. Three things happen when VGS is equals to 0 and VDS is increased from 0 to a more positive voltage. Number one, the depletion of region between P gate and the N channel increases as electrons from N channel combine with the holes from P gate. Increasing the depletion region decreases the size of the N channel, which increases the resistance of the N channel. Even though the N channel resistance is increasing, the current ID from source is drained through the N channel is increasing. This is because VDS is increasing. Now let us see JFET operating characteristics of pinch-off. In JFET, pinch-off voltage refers to the threshold voltage below which the transistor turns off. The pinch voltage is the value of VDS when drain current reaches constant value or saturation value. If VGS is equals to 0 and VDS is further increased to more positive voltage, then the depletion zone gets so large that it pinches off the N channel. Now let's see JFET operating characteristics saturation. At the pinch-off point, any further increase in VGS do not produce any increase in VD. VGS at pinch-off is denoted by VP. ID is at saturation or maximum. It is referred to as IDSS. The ohmic value of the channel is maximum. Now let's see JFET operating characteristics. As Vs becomes more negative, the depletion region decreases. Now let's see JFET operating characteristics. As VGS becomes more negative, the JFET experiences pinch up at lower voltage VP. ID decreases, VDS is less than IDSS even though VDS is increased. Eventually, ID reaches at 0 ampere. VGS at this point is called VP or VS. VGS, cutoff voltage. And here is the graph showing the operating characteristics of JFET. Now let's see JFET operating characteristics voltage control resistor. The region of the left of the pinch of point is called ohmic region. The JFET can be used as variable resistors where VGS controls the drain source resistance RD. As VGS becomes more negative, the resistance RD increases. As I have said earlier, there are two types of JFET, that is N-channel JFET and P-channel JFET. Now let us see what is N-channel JFET. An N-channel JFET is a JFET whose channel is composed of primarily electrons as the charge carrier. This means that when the transistor is turned on, it is primarily the movement of electrons which constitutes the current flow. Here G is gate, this is drain, and this is source. Now let's see N-channel characteristics. The curve which shows the graph of the drain current ID versus the gate source voltage and VGS, and this is the JFET N-channel JFET characteristics curve. The ratio of channel in drain current del ID to the changes in gate source voltage del VGS. Changes to VGS do not directly increases or decreases drain current ID. Now let us understand what is p-channel JFET. The device could be made of p-type bar with two n-type gates or shown figure. The principle of working of n-channel JFET and p-channel JFET are similar. The p-channel JFET behaves the same as n-channel JFET except the voltage polarities and current direction directions are reversed. The current is carried. The only difference between them is that in n-channel JFET, the current is carried by electrons, while in p-channel JFET, it is carried by holes. Let's see p-channel JFET characteristics. As Vg increases more positively, the depletion zone increases, ID decreases, ID less than IDS. Eventually, ID is equals to 0 ampere. And this is the graph showing the p-channel JFET characteristics. See the JFET transfer characteristics. The transfer characteristics of input to output is not as straightforward as in JFET as in BJT. In BJT, beta indicates the relationship between IB input and IC output. In a JFET, the relationship between BGS input and ID output is little more complicated, and it is given by ID equals to IDSS 1 minus VGS VP whole square. JFET transfer curve, and this is the curve for JFET transfer curve, and this graph shows the value of ID for the value of given VGS. Now, this is talk about the junction field effect transistor application. Here are the some applications, and they are JFET is used as a switch, JFET is used as a chopper, JFET is used as buffer, JFET are used as oscillator circuits, and JFET are used in cascade amplifiers. And here is the advantages of JFET. JFET has high impedance, JFET are lower power consumption devices, JFET can be fabricated in a smaller size. As a result, they occupy less space in circuits due to smaller size. Now let us see some disadvantages as well. It has low gain bandwidth per dot. The performance of JFET is affected as frequency increases due to feedback by internal capacitance. Thank you.